Hi everyone, in this video I will introduce algae biofuel, a renewable fuel made from microalgae. I'll explain what algae biofuel is, how the biological source is grown, how the fuel is produced, its current development success, its carbon footprint and ecological impact, and the way it has been commercialized to the public, and finally my own recommendations for the next steps. Microalgae are tiny photosynthetic organisms that grow in water. They can grow in freshwater, saltwater, and even wastewater, which means they do not take farmland away from food crops. Algae grow very fast and can double in mass within years because they use photosynthesis. Algae absorb carbon dioxide and sunlight to produce sugars, which they later convert into oils called lipids. These lipids are the key ingredients used to make biofuel. Algae are usually grown into two main systems: open raceway ponds or closed photobioreactors. Producers add nutrients like nitrogen, phosphorus, and sometimes bubble in extra carbon dioxide to speed up algae growth. During the daytime, algae perform photosynthesis, removing carbon dioxide from the air. At night, they carry out cellular respiration, just like other organisms, using some of the stored sugars for energy. The goal in algae farming is to maximize photosynthesis so the algae produce large amounts of oil. To produce algae biofuel, the algae biomass is first harvested and separated from the water. Then the cells are broken open to extract lipids. The lipids are chemically refined into biodiesel or biojet fuel. The remaining biomass can be fermented into make biogas or as fertilizer or animal feed. So the process includes photosynthesis to grow the algae, extraction of oil, and then chemical conversion into renewable fuel. Algae biofuel is still in research and pilot scale development stage. The U.S. Development of Energy Funds made many algae biofuel projects. Companies like Sapphire Energy, Algenol, and ExxonMobil have operated pilot farms. A few airlines, including United and Qantas, have already tested algae-based jet fuel in real flights. Although it's not widely available yet, progress is steady and costs are slowly decreasing. Algae biofuel has the potential to be close to carbon neutral. During growth, algae absorb carbon dioxide through photosynthesis. When the fuel is burned, the carbon dioxide release is roughly equal to the carbon dioxide that algae absorbed, creating a balanced carbon cycle. However, the actual carbon footprints depend on the energy used for pumping water, harvesting algae, and processing. With renewable electricity, algae biofuel could become a very low carbon fuel, especially for aviation. Economically, algae biofuel is still expensive, around $5 to $10 per gallon at pilot scale. But if technology improves, algae fuel could reduce dependence on imported oil, creates new jobs in biotechnology, and support rural and coastal economics. In the long term, algae biofuels could be a major part of the sustainable aviation fuel industry. Companies and research labs have tried to educate the public about algae fuels through outreach programs, websites, and sustainability campaigns. The message is usually focused on reducing carbon emissions and showing that algae grow without needing farmland, which helps avoid food versus fuel conflicts. Based on what I have learned, algae biofuel is scientifically promising but still too expensive. The best short-term goal is to focus on aviation fuel because airlines are actively searching for new low-carbon options. My recommendation is to invest more on improving lipid extraction efficiency and lowering the energy costs for algae cultivation. If funding were not a problem, I would build a large network of closed photobioreactors powered by solar energy using genetically engineered algae strains with higher oil content, and develop automated harvesting systems. This would dramatically lower costs and make algae biofuel commercially viable much sooner. That's what I want to talk about algae biofuels, and these are my citations. Thanks for listening.